Hello, everyone. How's everyone doing?
David?
Um, let's give everyone a couple of minutes to, and then we'll get started. Okay, let's get going. I see we have Gilberto on the call. Hi, Gilberto.
No.
Have we met before? Is this your first time joining us?
Yes, it is the first time in this meeting. I am jumping around the different streams about Chiplet. I am trying to get up to speed. So I have subscribed to everything. But I am not sure exactly this is what it is about. As I said, I am jumping around the meeting. So I'm not sure if I'm in the right place. Let's put it that way. I'm here to listen.
Okay. All right. Okay. What's your interest in chiplets in general?
So I am coming from a company called OpenChip based in Barcelona.
Okay.
We are working a chip for high performance compute at the moment for data
Very nice.
centers. And we are planning to use chiplet technologies to build that chip. And one of the things I want to check is whether or not there is a possibility to reuse the chiplets we are building in other markets. And what do we need to be careful
Okay. I see.
to make sure it happens? So we're going to do it anyway. So I want to say, okay, can we make them compatible with third parties? Can we reuse them? And what will be the business case? So that's what I am looking for, David.
Okay, very nice. Thank you for this background info. I'm one of the colleagues for the CDX. I'm not sure how familiar we are with CDX, but maybe a quick intro. CDX stands for Chiplet Design Exchange, and we focus on two main areas when it comes to chiplets. One area is data and formats for exchanging for chiplets, right? What data do we need for chiplets? What formats are there? Things like that. The second area that we have worked on is workflows. So the data, data and formats. These are kind of from chiplet providers' point of view, what data needs to be provided to the upstream workflow for integrating chiplets. And then the second area that we work on that's exactly adjacent to this is the workflows. How do we integrate chiplets into systems, right? Based off of these file formats. What do we look? What steps do we take, and so on. So those are the two areas that we focus on. if you go on the contribution database and search for ODSA white papers, you should see some of the contributions that we have done covering workflows and file formats. Right now, we have we meet every Thursday at this time, but we alternate every week. The topic we focus on this week is SIPI. And next SIPI is going to be in 2 weeks. Then next week is test design kit. But kind of still discussing exactly what do we focus on or from test design kit point of view in terms of data definition and so on.
Thank you, David, for the introduction.
Yeah.
So I'll be joining for now when I can. Next week I am actually Mobile World Congress. I might not be able to join, but at the moment I will try to explore a little bit what is in the website and try to get up to speed.
Okay, very good.
Thank you for the introduction. I'll listen to you guys. I don't want to interrupt you guys. I'll try to get up to speed.
Yep. Sounds good. Okay, switching topic then. Did anybody attend the IEEE call yesterday? I missed it. I got confused by the time zones.
I did attend that.
How did that go?
It was, my view is it was just an introductory call. It was a call where people went, the program manager there for this IEEE collection of standards went over the processes to follow and went over the membership. And then Sandeep at the end gave a brief overview of 3D blocks. They talked about the importance of the scope of the effort, and they did show a description of the scope they have in mind for this. And one of the things that I'm really interested in is I think the scope they're talking about implies that the standard is going to have less in it than what 3D blocks can express right now, because some of what 3D blocks expresses right now, I think, is beyond that scope. But I didn't ask that during the meeting. I think it's implied though.
Yeah, okay.
One of the things that interested me was the types of members that were there. They had representatives from the EDA companies and also representatives from Intel and TSMC and ARM and Expedic. I thought that maybe there would be some representatives from OSATs, but I don't believe there were any OSATs represented there. And I thought maybe there would also be representatives from other design companies that spend a lot of time with 3D IC design, such as AMD or NVIDIA, but they didn't have representatives there either. So it looks like, to a large extent, the membership in this IEEE work group is similar to the membership that TSMC has had in its kind of 3D blocks consortium, because they've been working already with Intel and with the EDA vendors, and that's largely the membership they have in this IEEE committee.
Interesting. So you mentioned scope. Can you share high level what the scope of that standard is going to be? You mentioned it's less than 3D blocks, so I'm kind of curious what will be in the IEEE version.
Okay, what I mean by that is they described the scope as being a standard for describing connectivity and physical properties of chiplets and of the stack for putting the chiplets together. I think that 3D blocks has gathered information about more than just connectivity and physical design. So I believe they've even gathered information that could enable power analysis and things like that. And so what I meant when I said those things might be outside of the scope of the final standard is because they describe the scope as being connectivity and physical design.
Okay. So would you say that that this 3D blocks, the way I understand it, is the way it started, right? It started with TSMC kind of having the initial version, and then everybody else jumped in and added their stuff. Would you describe this IEEE effort more similar to the initial version, to the basic version that TSMC had in mind in terms of just connectivity and how you stack things and leaving all the other goodies out that were later put in?
It seems to me if they're going to be strict about that scope, but I guess that will remain to be seen, because another thing they mentioned at the meeting is that they're going to provide access to the Rev 3 3D blocks, or version 3 of 3D block specification. And so that's a version that has gone way beyond the original
Yeah.
version and has included a lot of that stuff. So that leaves it unclear to me whether they're showing us the version 3, but then they intend not to have the standard cover all that or not. But like I said, if the standard attempts to cover everything that I think is in version 3, then I think it's going beyond what they described as their scope.
Yeah. Interesting. Interesting. So how is the how are the logistics of that IEEE work group going to happen? Do they have targets, plans when they want to complete the work and publish it? Are they ready to do it, or?
Well, okay, as far as logistics, they did say in the meeting that they plan to meet every second week. Originally, they were thinking it would be every second week on a Friday, but during the meeting, we decided instead that Thursdays will work well. So every second week on Thursday will be the meeting time, I think from 8 a.m. to 9 a.m. Pacific time. So maybe the next meeting, I don't think they actually put it on the schedule yet, but maybe the next meeting would be Thursday next week, or maybe Thursday this following week.
Yeah.
Um,
Okay.
and they said they don't know yet how long this is going to take. The Sandeep said, well, maybe a year, maybe 2 years to go through this whole process. During the meeting, I asked for a roadmap because I wondered if Sandeep or others had some roadmap in mind for like what phases this work group would go through in the process of deciding on the standard. And I think he mentioned verbally that he had something like that in mind, but it's not something he shared yet.
Okay. Interesting. Were any of the other foundry representatives there? Global Foundry, Samsung, SK Hynix, any of the memory guys?
No, I don't think so. So that's why I mentioned that the membership was largely similar to what TSMC already had as a consortium. So actually within SI2, we were meeting with Samsung representatives and trying to convince them to join this IEEE work group, because we want in the end goal, as an end goal, not to have an IEEE standard and a competing Samsung standard. Since Samsung has their 3D code.
Yeah.
So we actually suggested to Samsung members that they join this IEEE work group, but they declined. they decided they stated maybe they will join later, but at least at the beginning they did not want to do that.
Interesting. Okay. Yeah, I guess we'll wait and see. So I'm guessing that I think you mentioned that before, but is it still the case that the participation is limited only to certain members with certain level of membership?
Anyone is allowed to participate who has the right type of membership in IEEE. And they call it it's an IEEE entity membership. So it's if you so David, is it true that you already signed up for the work group and you just weren't able to make it to that first meeting?
I don't have if the participation is limited to members with entity membership, that will exclude me. I wanted to join and just listen to the first meeting, see what they say, but I just missed the time zone thing. Is always confusing me. But all right, so if it's limited to only certain membership levels, then that would exclude a lot of people.
If you're not the entity of the CPE, you still can join once as observer once.
Yeah, right. That's right. You could come to one meeting as an observer, if you're not an entity member.
Okay. Oh, okay. Yeah, well, I guess I'll do the next one. Then, since I missed that initial, I'll do the next one. Maybe each one of us here can alternate to attend once, and then we can huddle and take compare notes.
Report back every week. Exactly.
Right?
Yes.
It's actually even better. It's every month, so we should be able to cover the whole year.
Oh, absolutely.
No, it's bi-weekly. It's bi-weekly. So
Oh,
it's
bi-weekly?
second and
Oh,
fourth.
Yeah.
Second and
Sec-
fourth of the survey. Yeah.
okay. Okay. Yeah, we'll see how that goes. And we'll try to monitor. This is these standardization efforts are fairly new, so I expect a lot of development and rapid development. How things are gonna go.
Michael was there and Pratus also there as well.
Say that again. I'm sorry, I missed it.
Michael from Siemens as well as the Pratus from Siemens also are attending.
Oh, okay. Yeah. All right. Yeah, that's right. They can report back what's happening. Yeah. Okay. That's interesting. Hey, John, welcome back.
Okay, thanks, David.
Are you whom are you with right now?
Back with Siemens. So
Okay.
just kind of getting back into the swing of things. Just don't have a lot to report, but was curious to see kind of what you guys have been working on the last couple of months. So I will be here going forward.
Okay, awesome. So we actually need you. This is the I guess the perfect timing to switch to the main topic of this meeting, which is the SIPI design kit.
Mm-hmm.
So we're in a little bit of a crossroads. And we will need your help with that. In the sense, the following. What we wanted to do with the SIPI kit is to describe interfaces on chiplets, right?
Okay.
And on both in terms of SI and PI, and meaning The intent there is twofold, right? Today when all the SI work happens, setting up simulations and validation and things like that, you have to rummage through standards, right, to the PDF files describing all the different pieces of the standard and signaling, and then set up the simulation, and then also on the checking side, right? What is a pass-fail criteria, right? You still have to go and rummage through that standard and find out what it is, right?
Absolutely.
Rummage through the PDF. So what we kind of the overall objective is to put any relevant data in a file such that some of this setup can be automated.
Okay.
Now I did go to the BOL group and talk to them about the interfaces, and they kind of shut down this idea, meaning that everything. Let me find the right words to describe this. The feedback that I got was things are fairly custom, and there isn't being how did I like to say it, that kind of trying to capture all the different scenarios and different cases that are needed to set this up. The information that is needed for SI simulations would kind of make this definition so broad that is going to be useless. That's how I understood the feedback. Now, I wanted to run that with to check that with you. Is still, is there a common subset that can be clearly defined? Right. For example, here is one thing that always comes to mind, right? When you have a chiplet, at least on the PI side, when you have a chiplet, somebody will come and tell you, hey, I want this much capacitance with this much impedance, right?
Yep.
So that's a straightforward capture, right? For a chiplet, if we can say, hey, here's 10 different supplies, and this is what we expect on these supplies, that's a good initial start, right?
Yes.
On the SI side, how do you think we can capture something like this?
So specific to BOW or for any interface, because like you said, I think, David, the challenge, and I'm thinking a little bit about like a UCIe channel, right? There's basically infinite different possibilities of how the UCIe channel can be configured. So we put, if you look at the UCIe spec, there's pretty baseline like frequency domain targets. So from like an interconnect modeling standpoint, I think it's fine to rehash the limits that are listed in like a BOW standard. It's just a question of, can we capture all of the different configurations, or how many of those different combinations should we be tasked with kind of covering, or do we just say maybe like a standard or an advanced long reach? Anything else that's custom, you have to do the consultation yourself.
Yeah, right. So kind of what I wanted to, the way I was thinking about this is, so yeah, I understand one of the differences between BOW and UCIe is BOW does not define channel requirements. UCIe does.
Correct.
Right. BOW just adds a margin, right? But that's
Yes.
Here's the I guess it's the best way to describe what we are trying to do is talk about a persona. So the persona I'm thinking about is I do not have the layout done yet, right? I'm at the architectural exploration stage where I'm choosing chiplets and I'm choosing interposer technology or substrate technology, right?
Hmm.
So at that stage, what I want you to understand is I have two chiplets with PHYs, with two different PHYs, right? These PHYs, I have no clue who provides those PHYs, right? To me, they come as a part of this, as part of the chiplet.
Yep.
And as such, I want to know what are the basic parameters of those PHYs, right? So now, when we're talking about basic parameters, typically you have the standard, right, which gives you the bounding box of, say, for example, clock jitter, just random pick, right?
Sure. Yep.
It says the TX side clock jitter limit is this much, right? But here I am as IP provider that my IP gets embedded into that chiplet. I can actually do better, right? I have characterized my chiplet and I know that my clock jitter is way better than that, right? So I would like to provide that information. Not only say, hey, this is my UCE and the target clock jitter is this much and I meet it, but I want to go first, I want to be able to do that, but then I want to go to the next step and say, it's UCE, the standard target is this much, but I can actually do this much better, right? And provide that information in a file. So now the persona that's looking to integrate these two picks it up and looks at it and says, okay, here is this chiplet with UCE with interface X, right? It doesn't matter what it is, right? That has clock jitter of this much and data bit skew this much, right? On the TX side. What is on my RX side, right? What can my RX side tolerate, right?
Yep.
And maybe some chiplets can tolerate higher than the standard, right? Higher skew, just because they want to be better than that, right? They would work with the target, but they could probably do better. Who knows, right?
Sure.
So
Yep.
so now I take these two pieces of information and I say, okay, let me see what technology do you use, interposer or substrate. How do I create my channel such that both sides work, right? I want to leave the any IBIS models and things like that, obviously outside of this definition, right? The vendor will provide me the IBIS models for me to actually run the actual simulation.
Right.
But now I can start doing channel planning, right? And channel planning means, okay, I create some channel, but the targets that this whole TX to TX channel RX, right? This whole chain, the target that needs to be met would come from the standard definition, right? That says, hey, here's on the RX side, here is the, it's actually standard X and it requires eye opening of this much, this high and this wide. So now I've planned some channel, kind of done some work. And when I come to running simulation, I don't have to go and manually say, hey, do this much swing and check for all of this stuff, right? Here's the standard that comes and tells me how much it is. And it's a pass-fail under different conditions. So this is kind of the overall team that I'm thinking about. I'm not sure if that makes sense, right? The idea is to simplify a little bit of that early planning flow, where first of all we work with better data, and definitely reduce the amount of rummaging to PDF files, right, which are hundreds of pages, and hoping that somebody gets it right.
Yeah. Yep.
Right. What is your overall opinion of this, and how do you think we can approach this?
So David, let me circle back to this the next call, so I can show you what we've put together, what Siemens has put together from the UCIe side. So basically, we took the approach on UCIe analysis to basically say, if you have a channel, so we know what the UCIe baseline specs are at the drive receive blocks. So kind of similar to the approach we take in our SerDes compliance, where we just assume spec compliance at the drive receive. Once you get the actual IP, it could be better, it could be worse, like you say. But for that initial kind of channel compliance that we know, what the spec says we should have, basically we just assume spec compliant drive receive and then focus on the interconnect only. So whether that's organic or silicon, it doesn't matter. It's just a matter of getting that S parameter in such a format that is compatible with kind of our UCIe compliance engine. But that's the approach that Siemens has taken for this kind of first pass analysis, is to say, let's take the drive receive characteristics out of it. Once you get that later on, kind of add that to the analysis. But any first pass you're doing, focus that just on the interconnect itself and assume good drive receive characteristics, basically spec compliant, whatever they will be. Then we can evaluate the performance with actual drive receivers at that point when we get them.
Okay. Yeah. So in that, what I'm thinking about is in that spec compliance, actually somebody being able to update it with the actual PHY characteristics, excluding IBIS models and things like that. But right,
Oh,
IBIS
I see what you mean. Sure.
Right,
Yes. Yeah, I see what you mean. So basically, what I would say is that the way our engine works right now, and it's not fully productized yet. We just have kind of AE where to get this to run, but we could operate it like that. So basically, it's a config file with all of the spec parameters. So that's a config file that we could change based on those other metrics. So if you knew from the outset that you had a better performing driver, we could just change the configuration parameters for that particular PHY. Basically just changing the assumptions that we make. But that's no problem. That could be done basically today.
Okay. Yeah. So it's that config file that kind of it would be I think it would be valuable to automate that, right? Definitely the basic compliance kit would basic compliance would be against the spec. That will be the default.
Yep.
Right. The ability for a chiplet vendor to come actually for IP vendor to come and say no, mine is better, and actually
Sure.
technically speaking, it could be worse than the spec. If your channel is better, probably right, the PHYs right, it will all compensate, right? Thinking in the case of
absolutely.
Bull, right? If you have a lot of margin on the channel, your PHYs could be a little bit worse, and the world is not going to end, right?
Agreed. Yep.
However, if your one PHY is worse and one is better, or right, these two are not going to talk to each other.
Yeah, it may not work. Right. Exactly.
Right. It's those combinations, right? Once we get into a situation where we have chiplets from 10 different people, 10 different PHY vendors, making sure that those work together. That's the part that I want to address.
Okay. Yep. So I took some notes basically about being able to mix and match the PHYs, being able to edit the config file for the initial kind of model-free analysis. Like I said, I think that should all be doable. So I'll talk to the Siemens side, David, and see what we can put together.
Yeah, we have. Let me do this in the. In one of we were discussing last year about what parameters to put and since we're not experts, we got a little bit lost along the way. And let me post minutes in the chat, and I'll the meeting minutes in the chat, and I will share them momentarily.
Okay.
To show you what we talked about.
Yeah, and I can absolutely review that before the next meeting as well.
If you scroll down, there is the meetings that are SIP, marked as SIPI. And here you can see we start talking about clock and clock rates, encodings, right? And data encoding rates, I diagrams, stuff like that, right?
Okay.
VOL, VOH, VIH, VIL, all these stuff, right? We kind of got lost about what is relevant, when is it relevant, when is it
Yeah,
in when is it in IBIS, when it's not in IBIS, right? We
sure.
definitely don't want to repeat any of the stuff that's already in IBIS or anything like that. It's those
Yeah,
configuration
absolutely.
parameters
Yep.
that we want to tackle.
Okay. Yeah,
Right.
I'll review this note, David, and then I will look at kind of how we have our UCIe configuration file set up now and see what parameters we can easily change. And then I
Okay.
guess we can sync maybe before the next meeting, if you've got a couple different like PHY instances, and then I could use those to play with those different configuration settings.
I do not have PHY instances, man. These are proprietary, right? So I do not have access to actual data.
Okay.
But maybe we can start with the whatever the BOW and UCIe have as a standard. Maybe HBM is also interesting in
Yep.
in a way, right? If we can capture those three, I think that would be good. Maybe
Yeah,
start
no,
with
that
the
sounds good.
standards. Right,
Okay.
start with whatever is in the standard, and I don't know if people will have stuff that's outside of the standard. Maybe, but I guess we cannot capture everything.
Yep. No, this gives a very good jump off point. So
Okay.
yeah.
Yeah. Okay. Yeah. Go to this. I guess majority of this on page. Starts here, bottom of page 3, and you can look down. Kind of what did we talk about?
Yeah,
And kind
absolutely.
of nail that down to some reasonable state that
Okay.
makes sense. Again, I don't expect that we need to be 100% perfect. If we can hit full coverage, that's great. But if we can capture the essence of what's in those standards in terms of parameters, what is important,
Yeah,
I
absolutely.
think that's going to be a good first step. We can
Yeah.
always go and add stuff if we forget something.
And like I said, I think we already have a very good starting point because we have a UCIe solution that basically does this right now. So
Okay.
we can use that. We can use that as a kind of the starting point for the other standards as well.
Okay. Yeah, that would be great. If you want to discuss some things offline, do let me know. Send me a note, and we
Absolutely.
can always talk. Yeah, and
Yeah,
it's
sounds
good that you're back. We need your expertise to help us out define
Yeah,
this.
absolutely. Yeah, it's good to be back. Good to help out again. So
Yeah,
look forward to it.
Yeah, fun stuff. Yeah. Okay. So I don't have anything else for today. Any other thoughts from folks? Any comments?
So, David, this is Bala from Siemens.
Yeah, Bala.
So, yeah, hi. Yeah, sorry, I joined a little late. So basically, last week we were discussing about this. The NAPMP was asking some suggestions on that standardizing this flexible parallel bus interface. That
Okay.
what is part of this 18 like IEEE 1838 for the chiplet testing, right?
Yes.
So so today we understand that each EDA companies, they have their own standard protocols, like in-house protocols, and so that could be a limiting factor for the test time optimization if they want to do the white noise optimization at the across the chiplets, right, for the concurrent testing.
Right.
Right. So, but I'm not sure, like, how do we take this to next step? Like, whether do we need to have some working group across the EDA companies? How do we address that? We as the person in charge of in the Siemens, like D Harrison. So he is aware of this request from the Guinea PMP. So, but then we need to take this to next step to see if there is a value add, right? So we
Yes.
can discuss or try to form some like a work group across the EDA company.
Oh
Is
yeah.
that
Oh, okay.
doable?
I remember last time we what we talked about. Sorry, today I'm in a SIPI
Right, right. Yeah.
mode and test. I had to temporarily put it in the long storage memory. You know. Okay, so what we talked about last time is who are the important people that need to get together and figure out how do we do next step, right? That would be Siemens. That probably we will be somebody from NAPMP. Maybe some of the other EDA companies would be good to
Right.
participate.
Yes. Yeah. So actually the question was started from the NAPMP folks, like a Purdue University professor.
Yes, yes.
Yeah. So maybe we can start with them, and is it going to be an official request to the EDA companies to solve this problem, or it's not? It's not of interest from the NAPMP, right? That we need to finalize.
Okay.
Right. So
Let me.
yeah, I'm also trying to reach out to Lee Harrison to further discuss on this, but he is on a conference call on the traveling across Europe this week. So I
Okay.
will have some readout from the Siemens side, like what they are planning it, right?
Okay.
And so this is still a earlier request stage at this moment, but we need to hear the consensus from the different tool vendors, right? So right now they have their own proprietary protocol, and they have some abstraction layers and infrastructures within the tools. But if they have to create some multiple flavors, right, like AXI, AHP, and things like that, so what else they need to enhance it in the tool, right? So I believe it is doable. It's a reasonable
Okay.
ask from the NAPMP,
Yes.
and there is a potential benefit of the test time. Then everybody will jump on it.
Yeah.
So, but we need to officially streamline this ask and bring in the right folks. That's our initial challenge.
Yeah. Yeah. Okay. I think I want to get some advice from Tony as well. What he thinks, how would be best to approach this, especially on bringing all EDA vendors together, and
Right,
see
right.
what they can agree on. Right. That's I think that's the knot that needs to be broken. Is what do EDA vendors agree on?
Right, right. Yeah, maybe in our internal meeting, like I'm working with Tony in the same department, so
Okay.
I can bring it up
Okay.
with Tony, and there is other test and 3D product managers getting involved in those meetings.
Yeah.
So I can just within the Siemens side, I know like everybody, like so who needs to be aware, and I can bring those people in. But other companies like Siemens and Cadence, like I don't know like how they plan
Yeah.
to bring in.
Yeah. So my feedback is that OCP would definitely be happy to host some of these discussion and act as a neutral, like the UN of test methodology, you know,
Right. Yeah.
to discuss what needs to happen, and we can quickly spin up definitions and things like that as long as the EDA vendors agree on, right? We can mediate that process, and we can provide the neutral ground where that that can be discussed. OCP is set up perfectly for that.
Right. And I could think of ARM could be a potential immediate benefiter because they are the uh, the owner of the AXI, and they have multiple players of the AXI with the CSS ecosystem and the chiplet they are penetrating. So they will be an immediate benefiter of this ecosystem, like standardizing this
Yeah.
gap, right? So we can think of once we reach out to the sufficient support from the EDA folks, and then try to bring in like the the industry leaders on the system knock side,
Yes.
right? So
Yep.
that way it will be a mutual benefit for the system knock folks and the eventually physical design folks also, like so that they don't have to route one
Yeah.
bus for the test and another bus for the functional.
Yeah. No, I do get the benefits. Test is like power. Right. Everybody
Right.
hates
Yeah.
it. Everybody wants to focus on the functionality, and then either the power guys come and tell you, yeah, your power is too high, right? It's not going to work. Or the test guys say, oh, no, I need those pins for something else, right? Go away. So.
Right. Yeah.
Right.
Yeah. I mean,
So,
sooner or later, there is going to be a strong pushback from the physical design community for routing this two set of buses, right? So
yes.
that time all these CDA companies will be jump and try to resolve these
Yeah.
problems, right? But
Yeah.
since now we have the favor of OCP and DNA PMP, so we can use that as a requirement start point, and
Yes.
so try to do something like upfront before getting complaints from the physical design community.
Yeah, I think that's a very good idea. Next week is a test meeting, so we can continue the discussion there. And also, maybe if you have somebody in mind to invite to come and listen to what we are talking and what we are asking, I think that's going to be a perfect timing to do that.
Okay, sure. Yeah, I'll try to surface my pitch here within the Siemens and try to
Okay.
influence a couple of people's like Vidya and Lee Harrison. Those are the two main guys. If
Yeah.
they signed up and on board, I think they know how to put this into the practice.
Okay. Yeah. Perfect. All right. So let's continue the test discussion next week then.
Okay, sounds good.
All right. Any other comments from the other folks?
No. Not from me.
All right. Okay. Well, thank you guys, and we'll talk again next week then.
Okay, sounds
Sounds
good.
good.
All right.
Okay, thank you.
Thank you.
Thank you.
Have a good one.
Okay,
Bye.
see you. Bye.
Bye.
Bye.